All right, welcome back. We're going to keep going along and do something different because this is what Saxon does. But I thought let's just stay in the same order. We're not going to change things. So we've talked about derivatives, the product rule. Imagine that. Somebody's phone is not turned off. But we've talked about derivatives, product rule. We've talked about the antiderivative, going backwards. I hope you've all done well with those. I know we've kind of gone back and forth a little bit. But let's go ahead and talk about something different. Yes, we're going to talk about graphs, something that we've done in the past. I would say on page 176, reading some of that is helpful. I'm not going to read it all to you. You've got a book, and that's just kind of boring right now. One thing I would like to say, if you have a function equals x squared plus 4, okay, we actually call it, that factor, x squared plus 4 will not factor. It would have imaginary roots. It never touches the x-axis. It's something they call irreducible. It's an irreducible function, okay, quadratic, because it cannot be factored and can never equal 0, okay? Thus, irreducible quadratic factors never cause a polynomial to equal 0. So if you ever see something like this inside one of our lists of things, you know it's not going to hit 0 anytime, okay? So, what does that have to do with anything? Well, let's recall something we've done in the past. So let's start with one that we have all done. If f of x equals, and then we gave you an x minus 1 times x plus 5 times x, let's just say minus 3, okay? Can you sketch a graph? Okay, this we have done before. It has some zeros. Okay, it has a 0 at positive 1, negative 5, and at positive 3. Okay, then we would go plug in numbers. If we went and plugged in negative 6, if we plugged in negative 6 minus 1, we would have a negative. Negative 6 plus 5, we would have a negative. Negative 6 minus 3, we would have a negative. And a negative times a negative times a negative is going to be what? That's right, negative. Okay? And so far, we've been able to pick other numbers. If we picked a 3, do you have a guess what it might be? Positive, negative 3. Sorry about that. Plugging in a negative 3 would be a negative, and a positive, and a negative, which would be positive. Okay? So in between all of these, we could have plugged in 0. Okay? And then we would plug in a 2. What color? Let's go to blue. We plugged in a 2 because that's the next piece that I have between the zeros. We plugged in 2, we would have a positive, and a negative, which would make it negative. And last but certainly not least, we might plug in a 4. A 4 would make this be positive, and positive, so it would be positive. It's going to switch every time. So it's going to start something negative, go to positive, go to negative, then back to positive. Okay? That would be a sketch of that graph. Okay? That's all review. We've done that before. Just kind of bringing that back to the forefront because it was last quarter when we did that. Okay? And until now, I told you, we can just alternate. Minus, positive, minus, positive. It's going to do that. Well, today, we're going to figure out when that might not happen. Let's consider if f of x equals x minus 1 times x minus 3. Now I'm putting a squared on the outside of x minus 3. Okay? So looking at the graph, do we still have zeros? Do we still have zeros at a positive 1? Yes. If we plugged in a 3, a positive 3, 3 minus 3 is 0. 0 squared is still 0. 0 times anything is still 0. Correct? So 3 would still be a 0. Okay? But this time we only have 2. So I'm going to plug in 0. 0 minus 1 is negative. 0 minus 3 is negative, but when we square it, okay? So what is 0 squared? Okay, well, sorry, what is a negative squared? 0 minus 3, so what's negative 3 squared? It will be a positive, okay? So a negative times a positive is going to be negative, okay? Let's plug in another one. Let's plug in 2. 2 minus 1 is positive. It's 1. 2 minus 3 is negative 1 squared. What's negative 1 squared? It's a positive 1. So it's going to be a positive. Now, I'm going to keep on going. So you're thinking, oh, it's switching the 7s. Yeah, so far it is. What if we plug in a 4? 4 minus 1 is positive 3. 4 minus 3 is 1. 1 squared is still 1. So a positive times a positive is, it's a positive. We've got 2 positives beside each other, okay? Because no matter what we plug in to this x minus 3, it will always turn out a positive, okay? So this graph is going to start negative. It's going to start somewhere over here. It's going to go up through 1. It's going to come down and hit 3, because that's a 0. But then it's going to turn back up and be a parabola, okay? So it almost comes down and parabolas back up. So when we have a squared, we're just going to say wherever you have that 0, okay, it will touch, but then go back in the same direction. So it touched from a positive, and then it will go back to a positive, okay? Very good. We're going to do another one. Let's see about, oh, they give a big long one, but I don't want to give one that long just yet. Let's do an f of x equals x minus 2 times x plus 1. Oh, I don't want to do a plus 1. Sorry. One more. X minus 4 squared times x plus 5 times x, I'm just going to do plus x squared. Will be nice, but I'm going to put 2 of the squares in there. Make it a little bit longer. So this is what we have. All right, so let's draw out our graph. Probably doesn't have to be quite that long, but that's what I did. So we have zeros at positive 2, a positive 4, a negative 5, 5, and what about this one? Would it be 0? Yes, it would. It would be 0. Okay? So x could equal 0. We're setting all those equal to 0. Then I'm going to start every time. What's happening at negative 6? Negative 6 minus 2 is going to be negative. Negative 6 minus 4 is a negative 10 squared. But a little hint, whatever you plug in, it's going to be positive. So I might as well just leave a positive there every time. Negative 6 plus 5 is going to be negative. Negative 6 squared, still going to be positive. So with negative times a positive times a negative times a positive is going to be positive. Okay? Now, what about here in between? It doesn't matter. You can plug in a negative 2. That's kind of the same color. Negative 2 minus 2, still negative. Negative 2 doesn't matter. It still has to stay positive. Negative 2 plus 5 is now positive. Negative 2 squared doesn't matter. It's always going to be positive with the squares. So negative times a positive times a positive times a positive is simply going to be Keeping on going, if I plug in the number 1, 1 minus 2, negative. Does it matter if I do this? No, it has to be positive. 1 minus 4 is negative 3. Negative 3 squared is positive. 1 plus 5 is going to be positive. Right? 1 squared is still positive. We have a negative times a positive times a positive times a positive. It's going to be what? Yeah, you guessed it. It's negative. What, Miss Evans? It didn't switch signs. I know. Because we were at the squared piece. So I'm going to keep going. 3. 3 minus 2, positive. Doesn't matter. It's going to be positive. 3 plus 5 is positive. 3 squared is positive. Everything is positive. And last but not least, I'm going to plug in a 5. 5 plus minus 2 is positive. 5 minus 4 doesn't matter. It's positive. 5 plus 5 is positive. 5 squared is positive. We've got a positive. I have 2 more that are the same. Okay? So we're going to look and make some connections. So positives to the left of 5, to the left of that 0 is positive. And then it goes negative, comes up and hits 0. Sorry. Comes up and hits 0, but then turns back to go negative again. And then it comes back to be 2, that's positive, goes up, and it's coming back down to this, but then it turns and goes positive again. Okay? Let's make a connection. Where are zeros? Where we had zeros that were squared? At 0 and at positive 4. So at 0 and at positive 4, whatever direction it was coming from, if it was negative, on the left of 0, it will be negative on the right. It's going to touch and go back the same direction. Okay? Also at 4. Whatever it was before, it will be the same after. It will touch it, but it will go back the same direction. Okay? So we can't just alternate plus, minus. Okay? We have to check. All right? Perfect. Now, they get into a little bit more that says, well, what if I don't want to just be squared? What if I want to do one with a cubic function? Okay, we're going to start out smaller. What if h of x, does it matter if I use h or f? It doesn't. And I'm going to give you an x minus 1 cubed times x plus 2. I'm just going to start out small. Let's start out small, easy. Don't go into what your book does and give you like 5 all at the same time. So, zeros, still going to find those the exact same way. Set x minus 1 cubed equal to 0. Cube root, we have 1 is a 0. X plus 2, we're going to have a 0 at x equals negative 2. Okay, so I've given you one that just has 2 zeros. And then I'm going to plug in. What happens if I plug in a negative 3? What's a negative 3 minus 1? Negative 4 cubed is going to be negative. Oh, let me not put that there. It's going to be negative. Okay? So cubic functions will still keep that negative if it's a negative. Okay? X plus 2. So negative 3 plus 2 is negative. So a negative times a negative will actually be a positive. Okay? Let's plug in. Can I plug in 0? It's between my two zeros, my two 0 points. 0 minus 1, negative 1. Negative 1 cubed is negative. 0 plus 2 is positive. So negative times a positive is a negative. So it's switching again, right? Last but not least, let's pick 2. 2 minus 1 is 1. 1 cubed is 1. It's positive. 2 plus 2 is 4. It's positive. This case, the cubic will go through, okay? It doesn't necessarily have to stop. It won't. No cubic functions will stop. They will always go through. Only your even functions, even degree functions will stop, turn back to the same direction. Okay? Cubic functions will not. They will keep going. So we start positive, go through our 0 to be negative, go back through our 0 to be positive. It looks something like a parabola-ish. It's going to keep going. Okay? All right, so let's look at the one in your book. They give you f of x equals. If f of x equals x plus 4 times x plus 2 to the 4th times, oh, they were mean to you in this one, x plus 3 times x minus 5 cubed times x minus 7 squared. Okay, they brought something in from what I told you at the beginning, but we'll have to go back and look at that. Just 1 second. So drawing this, let's find our zeros. Here we go, x plus 4, we would equal negative 4. 1, 2, 3, 4. That's a 0. This piece, x plus 2 raised to the 4th, is that ever going to cross the x-axis? No, it will not. Because it is, oh wait, yes it will, sorry. X plus 2 will, it's the next one that I'm worried about. Okay, sorry. We can still have a 0 here because I plug in negative 2. Yeah, sorry. It's the next one that I'm looking at. X squared plus 3. Subtract 3, take the square root. We can't take square roots of negatives. So this will not have a 0. Because x squared plus 3 can never, ever be 0. Okay? Just not possible. The next piece, x minus 5, we can go 1, 2, 3, 4, 5. We'll have a 0, and 7 will have a 0. I think they just simply ask for what are the zeros. 4, negative 2, 5, and 7 are your zeros. You have to know that this one will not have a 0. I'm going to keep going and say, can you sketch the graph? I'm plugging in a negative. Plug in negative 5. I'm going to have a negative. I'm going to have a positive. To the 4th. So we might even can say, hey, right here, this 2, it's going to touch. And go back to the same spot. Okay? At 7, it's going to touch. And go back the same direction. Okay? So whatever it is on one side of it, it'll be on the other. Sorry, I'm getting ahead of myself. Okay, so we're plugging in negative 5 plus 4. It's negative. Negative 5 plus 2. Negative 3 to the 4th is going to be positive. Negative 5 squared is going to be a positive. Plus 3 is going to be a positive. Negative 5 minus 5 is negative. Negative cubed is still be negative. Negative 5 minus 7 is negative. Negative squared will be positive. So I've got 3 positives and 2 negatives. Negative times a negative is going to be a positive. Whew, that was a lot. If I plug in negative 3, oh gosh, see what I did? It's a negative 4 there. So if I plug in a negative 3, negative 3 plus 4 is going to be a positive. No matter what, that's a positive. No matter what, that's a positive. Negative 3 minus 5, still going to be a negative. Negative cubed is negative. Doesn't matter what this one is, it's always going to be positive because it's a squared. So I've got 4 positives and 1 negative, which means it's going to be negative. Now I can go ahead and plug in 0, okay? But no matter what, where we touch, on the other side has to be the same, okay? No matter what, on the other side it has to be the same. So here we go. I'm going to go ahead and skip. We'll see if it changes in this one. I'm going to plug in a 6. So 6 plus 4, going to be positive, positive, positive. 6 minus 5 is 1. 1 cubed is positive. 6 minus 7 doesn't matter. It's going to be negative times, or negative squared is going to be a positive. So all of those will be positive. So it switched. So it was negative, negative, and it's going to switch to be positive. Where it touches, it should be the same on the other side. Okay, we could check. If you really wanted to check what happens at 8, got a positive, a positive, a positive, a positive, and a positive. That's right, it's going to be the positive. Okay, so your graph should look like, okay, it's coming from positive to negative. It's going to touch at 2, go back down to be negative. It's going to come up to be positive, come down and touch, and then go back up. Okay? That would be what your graph looks like. So where would it touch and go back? At a negative 2, right there, and at a positive 7. It will touch and go back up because you have an even exponent. Even exponents will touch and go back the same direction. Odd exponents will simply go through the x-axis just like every other normal graph. Okay? Example 33.2 says, which of the following graphs is most resembles the graph of x minus 1 squared times x plus 2 squared? Well, you know, zeros are positive 1 and negative 2. So positive 1, that excludes A immediately. They put them at the wrong spots. And C, they put them at the wrong spots. B and D have the zeros correct. Okay? At positive 1 and a negative 2. Now, I don't even have to plug in any numbers to know which one has to be correct. Because no matter what, at the positive 1 and at the negative 2, they have to touch and go back the same direction. Okay? So D must be correct. All right? I think we've probably gone a lot and a lot over. So I'm going to go ahead and stop. We'll finish this later. All right. Have a great day, and I'll talk to you.